Hi there. Today we're going to be talking about similar triangles and proportional relationships. So to begin with, let's talk about what is similarity. And as I look at these pictures, I can see some examples of things that are similar versus not similar. So a bear versus a monkey, not similar. Two butterflies, similar. Two triangles that are both right, similar. Two shapes that are not even close together, not similar. So what are similar figures? Figures that have the same shape but not necessarily the same size are similar figures. So think to yourself, like if I had a replica of a Navy ship, the Navy ship and that replica would be similar figures because they are the same shape but not necessarily the same size. So are these two heads similar? No, because even though they are showing a picture of the same thing, those that one face is scrunched and one shape is stretched out. So it has to have be thought of as an enlargement or a reduction, but with no irregular distortion. So it can't scrunch it, can't make it fat. So these are all examples of similar figures because one's an enlargement or a reduction of the other with no scrunching. So when two triangles are similar and have the same shape but different size, they are called similar triangles. And the similarity is expressed with the weird following symbol called a tilde. And so a statement might say triangle ABC is similar to triangle PRS. And if I were to look at that in a diagram, that would be something like ABC is similar to PRS, where the first letters, second and third, are corresponding. Whereas on the second example, triangle 1 is not similar to triangle 3 because they're not. It's not an enlargement. It's kind of an enlargement and a shift. So big idea, they have the same size and they've got corresponding. So in this diagram, what sides are corresponding? You'll see A is marked with one arc and D is marked with one arc. So if I were to write a similarity statement, I would write triangle A, B, C is similar to, well, A matches with D, so triangle D. B, which came second in my list, matches with E, so I'm going to write that second in my list. And C matches with F. So because C is written third, I'm going to write F third. The other thing that I need to know is that the corresponding set two figures are proportional. So because one's an enlargement or a reduction, the side lengths may not be exactly the same, but they should be proportional, making things the same shape. So as I look at this, if I were to look at a couple of fractions, AB, which is this segment right here, AB over DE, so that matching side on my second triangle should be proportional to, I go back to the first triangle, BC, and its matching spot on the second triangle, EF. Okay, AC, go back to the first triangle, what's the matching side on the last triangle, DF. So those side lengths are proportional. So if I had to list all pairs of congruent angles, okay, based on this statement right here, because A comes first, I'm going to mark it with one arc, R comes first. So those two are corresponding. So I would say angle A is congruent to angle R. Angle B comes second, I'm going to mark it with 2, angle S. So angle B is congruent to angle S, and angle C is congruent to angle T. And then write a proportion that relates all the corresponding sides. So what would that look like? Go to the first triangle, AB. Okay, go to the second triangle. What is that corresponding side? Well, AB matches with RS. So AB over RS is equal to, go back to the first triangle, and I've got to always go back to the first triangle first, BC over the matching side on my second triangle, ST, which is equal to, go back to the first triangle, AC over RT. So these sides are proportional, and you'll see what I mean, as we look up at different examples. So If G, H, and K is similar to P, Q, and R, determine which of the similarity statements is not true. So is HK similar to RQ? Well, are they corresponding sides? HK, is that matching to the same shape on the other one? Yep, so that one's good. Okay, B, GH over GK over PQ. So far, so good. GK over PR. So those are matching sides, so that one's checks out. And is angle K similar to angle R? Well, they're in the same position, so yes. And is angle H similar to angle P? Well, those are not in the same location on the same triangle, so they are not similar. So yes, that is not true. Okay, find the missing angle to determine similarity. So one big key idea is this. Two angles must be congruent to be similar. And the reason this is remember when we were talking about how a triangle adds to 180 degrees if I add all the interior angles? If two are the same, the last one by default has to be the same. So I'm going to look at these two triangles. I'm going to ask myself, are they similar? So I'm going to take triangle number 1 and I'm going to determine what that last angle is so I can see if I have two matching angles, because right now I have one matching pair. There's two that are marked as 80, but I don't know if a second pair is congruent because this angle is missing and I think it should be 65, but I don't know. Let's check. So I'm going to take 180 and I'm going to find, we're going to start with this missing side down here that I just filled in. So 180 minus 80 minus 65. And if I use my calculator, 180 minus 80, let's clear this, clear history. 180 minus 80 minus 65, and I get a remainder of 35. So this 35 matches with this 35, this 80 matches with this 80, and my rule says two angles must be congruent to be similar. So I have reached my criteria. I know these two triangles are similar. Similar because two angles are congruent. So let's look at the second triangle. As I'm looking at my diagram, it looks kind of weird. Notice I have a little triangle and the big triangle. And I notice that two of the angles are marked as 27. So remember my rule, two angles must be congruent to be similar. Well, I have one angle so far. Is there a second one? Notice angle G is the top angle in both the little triangle and the big triangle. So this angle is congruent or the same size for both. So I now have two angles, and I can say triangle 2 is similar because it has two angles pairs which are congruent. Let's try a different example. So if I'm looking at this, we'll do number 3. If I look at this example, I notice I have one pair of angles that is congruent. These are different, but remember I need to have, I'm going to check out this last side to see maybe if that angle matches 39 or 41. So I'm going to take my calculator and I'm going to take 180. I'm going to find this angle D. And if it matches 41, then I might be in luck. So 180 minus 39 and minus 72. That is 71. So I marked this angle up here with 71. Well, now that I'm to this point right here, I can see that while I have one pair of angles that matches 71 and 39 do not match this 41 degrees. And remember, I've got to have two pairs of congruent angles, and I'm not going to have two pair of congruent angles. So I'm going to say not similar, not two pair of congruent angles. And if I look at this last shape, there's no measures, but F is equal to H, G is equal to D, so this would be similar because I have two pair of congruent angles. Sweet. So let's talk about this one other way to talk about similarity. So I know if two triangles are similar, they're going to have all proportional sides. So I should be able to have a proportion that works. So if I look at 7.5 over 5, does that equal this other proportion, 6 over 4? Now, right now, they don't look the same. I can't tell if they're the same. So I am going to use my handy dandy calculator and simplify both of these sides and see if they end up equaling the same thing. So 7.5 divided by 5 is 1.5. And 6 over 4 is also 1.5. And because I have these pair of proportional sides, I can determine that these two triangles are similar. So that's how I tell if they're similar. I make a proportion of the sides that match up. Notice that 7.5 and 6, which are both on top of these fractions, are on the bigger triangle. 5 and 4 are on my smaller triangle. So now that I know they're similar, how do I determine this length of x? Well, I'm going to use these proportions, and I'm going to set up a proportion, but just with my missing side. So you'll notice this matches this, 7.5 over 5. So those matching pairs is equal to, go back to your big triangle because I started with my big triangle, 4.5 over x. Now, what do I do from here? Well, here's how I do it. I am going to cross multiply. Sometimes people call this the butterfly method. When I cross multiply 5, I'm going to multiply 5 by 4.5. So you'll see that operation right here. And then I'm going to set it equal to this diagonal multiplied together. So 7.5 times x. I'm going to simplify. 5 times 4.5 is 22.5. I can simplify this side over here because it's got an x. So how do I get rid of that 7.5? Remember, this was multiplication. I just multiplied those together. So to undo that, I'm going to divide. And in my calculator, 22.5 divided by 7.5 equals 3. So x, or my missing side length, is equal to 3. So let's go ahead and solve one more problem. So how would I set this up? Well, I'm looking at my triangles. Now, pay attention to where these arcs are. A doesn't match with R, it matches with P. So if I want to find a missing side length, let's find C first. So I'm going to write a proportion. Now, one of the numbers I know is 10 on the big triangle. Now let's find its matching side length on the little triangle. 10 goes in between the one that's marked with one angle bar and no angle bar. So 10 matches up with this length of 5 on the smaller triangle. So 10 over 5 is equal to, now I want to use C. I want to find C. So I'm going to use C from the big triangle. I'm going to just leave it in that top spot. It's going to be an unknown for right now. And now I need to find the correct denominator. Well, C goes between the one that has 2 angle marks and the one that has 1 angle mark. So between 2 angle marks and 1 angle mark is the length of 4. So I have this proportion. Remember, I cross multiply. 10 times 4 is 40. 5 times C is 5C, and I'm going to divide. 40 divided by 5 is 8. So my length of C is equal to 8. Well, what if I wanted D? Well, I'm going to set up a similar proportion, except for I need to make sure I include D this time. So D, and might as well just start with that proportion. If I want to include D, and I got to choose a different color, otherwise you won't be able to see it. D for my small triangle, and you'll notice that this time I put it on top. It doesn't matter what order you put your numbers as long as you go in the same order. So because I started with the small triangle is going to be my on top. So on small on top. D on the small triangle matches with what on the big triangle? Well, D goes between the 2 arcs and the no arcs. So the 2 arcs and the no arcs matches with 6 on the large triangle. And on the small triangle, okay, remember I want to make sure I have a proportion that has 2 side lengths. So I have got 5 on the small triangle. And what does that match? It's between the 1 arc and the no arcs. So that's over 10. And I'm going to cross multiply. 6D times 10 is 10D. 5 times 6 is 30. And how do I solve for D? I divide by 10. So D is equal to 3.